This time on Jairus of All, I make the Blades of Chaos look like the Blades of Chaos, and I make them work. If you watched the last build, the screws weren't ground down in this, and it wasn't to the finished point that it is now, but I tested it and it didn't fly right. So I had an idea. I have many ideas on how to make these fly right, but I had one very easy idea: to change the location of the handle, which goes back to the whole rocket science thing when I talked about string testing rockets in build number 2, I believe it was. What we need to pay attention to here is the imaginary line that would extend straight towards the earth from the swivel point that will be on the end of the handle. And that travels right through the blade, and then you can determine where your center of drag is and where your center of mass is from that. On blade number 2, I moved the handle forward towards the front blade a little less than 3/4 of an inch. And it's pretty obvious that that is hanging at a better angle because the center line from the swivel point puts more of the blade behind that center line down from the swivel point than on this one, which should make it fly right. And spoiler alert, I already tested it and it works. Come on, I'll show you. This is the one that doesn't work. And if I swing it around, it doesn't necessarily go blade first unless I hold the rope so that it should be blade first. But if I swing it like this, it just kind of goes wherever. Part of that is because my swivel point has a fair amount of friction in it because it's just one of these little thingies. But that also means that my center of drag is not far enough behind my center of mass for this to fly the direction that it's supposed to, which is front blade first. This one just has the handle moved forward slightly. Other than that, same thing. And once I get this spinning fast, it doesn't matter. If I turn the rope, it still stays blade first almost entirely. But like I said, these swivels have a fair amount of friction to them, so it's affecting it. When I put the ball bearing on the end, it's gonna be a lot better. But that slight movement of the handle puts my center of drag much further behind my center of mass, which makes this far more stable in flight than the other one. And the faster I swing it, the more stable it flies. Blade first, which is kind of terrifying. This is relatively heavy. When it's sharp, it can be a lot of fun. Can't help myself. I gotta try it. I gotta give this a shot. Oh, I got this, here we go. Yes! I have what I think is a very good idea for how I'm gonna weather these to make them look like they do in the game. I printed a picture out. This is a printout of the exact one that this is going to be. I had to get the black off of it so I didn't use up all my ink, but the outline isn't perfect, but you can see what the weathering looks like on it. It's pretty beat and it's dark. It's not a highly polished, perfect sword. In order to get it to this random dirty look though, I do need to clean off the grinder marks because those are too uniform to make it look like that. Flap discs. Pro tip, aluminum loads everything up, but if you spray WD-40 on it, it doesn't. At least not as bad. So, flap disc time. This is only a test.
This is a test. I repeat, this is a test. Please do not panic.
Because I need to see if these make the sword look the way I want it to look with the next thing. I have tape on the sword because I want one side to get treated before I do the next thing and one side to get treated after and see which one works better. This is the side that gets treated before, the next one gets treated after. But I need to use aluminum black on the aluminum, and then I need to use gun blue, which is steel black on the steel, obviously. This gun blue is working really well. Obviously, my cleaning method of using carb cleaner and a blowtorch worked pretty well. That's a All patented cleaning process right there. You know what? I just got a little bit of this on the aluminum. I wonder if I have contamination right there. Tell you what though, she's getting dark. Give this a little shaky shake. That's a technical term. These things do work really well. It's not surprising that this aluminum black is not being super consistent on the aluminum because the aluminum plate that I used was 3003. I don't know what alloy the screws were. I don't know what alloy the weld rod was, but I do know that I used 4043 filler rod with the TIG. But so I have 1, 2, 3, 4.
1, 2, 3, 4.
Different alloys of aluminum in this thing. So it is turning it black, it's just not consistent. And I may have contaminated it with steel. There's a lot of things that could be going on with the aluminum, but I can turn it black. It just takes some time. I think if I apply more, I might be able to get it. Now that aluminum stuff's been on there for a while, it's getting dark almost everywhere. Doesn't matter if it's perfect because this is only a test.
This is a test.
And if you want to get this stuff, I'll put a link to it in my Amazon store, affiliate link in the description so you can find it easily. And actually, while you're at it, if you watched the last build video, I was using my buddy's DeWalt grinder and I did not like that thing at all compared to this one. And I'll put a link to this one too. This is less expensive than the DeWalt and it's better. It was reviewed by AVE and he said it was fantastically well made. It's like $90 on Amazon. I'll put a link down there to it so that you can get this exact one, WSG 8-115. It's a fantastic grinder. I love this thing. I've abused it. It just keeps on going. Speaking of abuse, it's time to abuse the sword. This is a needle scaler and it beats stuff up with what it says to be 4,000 hits per minute. And I'm gonna try to make the surface look weathered with this. We'll see how it works. Woo-hoo! That is incredibly loud on a big hollow piece of aluminum. I'm gonna put this on. The reason I blacked one side and didn't do the other one before I beat it up was to see how well this would stay on, see if I should do it before or after. Now I'm blacking the side that wasn't blackened. I did a whole video on this at one point, whether gun blued stuff is food safe. Selenium is what is in here that's a poison. That's why it says poison on it. Danger, poison, corrosive. It is corrosive because it's full of acids, but it's an acid that has selenium in it. It deposits that on the surface. It absorbs light instead of reflecting it. That's what turns it black. The layer, if you apply this correctly and you put this cold gun blue on and then you rub it back with steel wool and you still have the metal be black, the layer is microns thick. And I calculated out how much you would actually have to eat to be poisoned by it, and it's an outrageous amount. I have a whole video about this problem because I gun blued kitchen knives and I needed to see if they were safe, and they are, is the point. If you want to go watch that video, I'll link it in the thing in the corner or whatever. Basically, you can eat with these if you wanted to. Well, after I clean them and wipe them off. You don't want to eat with them with the acid still on there. But now, more tests. So I have two different ways that I want to try to polish this back. Steel wool on pre-treated, steel wool on post-treated, post-beating up on aluminum and steel. See what the result is from those. It's very strange that this section came off entirely and this one did not. I feel like I should try a little bit of this side more down here. Yeah, see, that's not just rubbing off entirely like it did right there. It's almost like it didn't even do anything. That's very strange. I'm gonna try something. Obviously, I need to be able to turn it black, and I want to do it this way because paint will, like, guaranteed come off. So this is kind of what I need to do. See, that's weird. I put it on, it turns black, and now that I'm rubbing it, it's just, it came off so easily. But it didn't on this side. That should be the same metal. I didn't use the aluminum weld rod back there. I don't know what's going on. If I'm I'm more gentle with the steel wool, it does work. Now it's time to remove the tape and test the second method of removal. And it looks like masking tape could be a method of removal because that peeled off a substantial amount of the black that was on the aluminum right there. This is all a learning process. I didn't even know there was aluminum black until about a week ago. The other way to get the gun blue and aluminum black off is with this electric file. At least I think this is gonna be the easiest way. I have a feeling this is gonna work well on the blade and not that well on the aluminum. It's probably gonna take off the weathering that I put on the aluminum. And 240 grit belt. The blade is shinier than the sides on the whole thing, so this is definitely what I'm gonna have to use because that would take years with that super fine steel wool that I have. So this is the answer for the blade. Let's see what it does to the aluminum. I was as light as I could be with this, and it just removes material too fast. It brightens the aluminum up way too quick. And on the picture, the sides of the sword are really dark, and they're very beat up. So I feel like I could almost get away with not even really removing very much with the steel wool on the aluminum parts of this, and it would look accurate to the game. But there's a bigger problem.
Houston, we have a problem.
When I was throwing this into the cardboard box, and then when I was weathering it with the needle scaler, all of the areas that I used the Aluma weld that were not completely backed up by plate behind it broke out or bent in and got messed up, and it causes a strong bond, but it's not gonna hold up to the stuff that I'm gonna do to it. So I need to go back to my friend's house and TIG all of the edges with actual real aluminum so that I can go back and fully weather this thing. But it's all a learning process, so it's okay. Be back in a bit. Oh. I need sword. I re-welded the whole thing again with the TIG welder. Then I brought it back and I ground it down, and then I started the weathering process, which you already saw. Basically just like sanding anything. You go up through the grits, and then I started applying the gun blue and the aluminum black. The gun blue worked pretty well, but the aluminum black didn't want to turn the aluminum black, and I have no idea why, because I cleaned it the same way I cleaned it before. I have no idea. But I did find a way to make it turn it black, and that was to hit it with the torch and then apply the aluminum black stuff. And that did turn it black. The funny thing is, on the aluminum black bottle, it says that you should use cold water to turn the aluminum black whenever you're trying to turn aluminum black with it. I knew that heat would make the reaction happen a lot faster, so that's why I hit it with a torch, and it did work. And then I went ahead and I hit the whole thing with the needle scaler and beat it all up to make it look more similar to the picture. And after I felt like it was sufficiently beat up, I started the polishing back process, removing the blackness from it. Since it didn't really matter whether I did it first or second, I figured I'd do that first. I had a feeling it might be easier to get everything turned black, and then I could knock some of it off whenever I was doing the needle scaler. I used the steel wool to polish back the black on the aluminum because the aluminum black is far easier to remove than the gun blue on the steel. And then for the steel, I used the electric file to polish back the steel parts and some of the aluminum. I wanted to get the edges shiny and differentiate them from the surfaces of the blade because that's the way it looks in the picture. And at some point in there while I was moving it around, I realized that it was sharp because I cut my thumb on it.
Oh, has a boo-boo.
And then after I had it looking basically the way I wanted, I hit it with a file to nick it and mark it up to make it look a little bit more weathered, a little bit more similar to the picture. I even tried to copy some of the gouges in the picture exactly onto the sword. And you may have noticed that I took the handle off, and there's a very good reason for that. I'm not just gonna relocate it, I'm actually gonna move it further back instead of further forward. That way I can use the 3D printed guard the way it's supposed to be used. But now I'll explain the physics behind moving the handle and doing what I did with it to make it look like this. Yeah. Curved handle. Okay, so here's the deal. Whenever I'm swinging the sword around with the chain, it matters where the center of mass is on the sword, and it matters where the center of drag is because that's what makes the blade go first. Now, if I can find the center of mass, which is relatively easy to do, then I know where that's at. So let's say the center of mass is right there. The point that it's connected to the chain to the center of mass is the line that, like, that's how it's gonna swing. It'll be straight out from the chain from that point. So then, if I knew exactly where my center of drag was, and I moved my point on the end of the handle, if I moved it that way so that it swung like that, then that would obviously put a different amount of the sword behind, because when it's swinging, you want this is my center of mass line. I want my center of drag to be somewhere behind that. So the thing is, if my center of drag is like right here or right here, if I change my swivel point on the handle to be up here, then this is better if it's there, because that moves the center of drag further back from my center of mass line, giving me a greater separation and therefore more stable flight. Now, if it's up here, then it's better to keep the handle where it's supposed to be, because that moves it further away from that line that's the center of mass. But I don't know where the center of drag is, but I can find the center of mass by doing this. If I take the sword and I lay it on this piece of metal that I have held in the vise, and I make it balance that way, I have balance like that, but that doesn't tell me where the center of mass does. But if I draw lines on each side of it, which you probably noticed those lines that were on the sword whenever I started doing the stuff to it, and then I turn it this way and find the balance point, and then I draw lines there where those lines intersect, that gives me my center of mass. And then I can just kind of eyeball it and see if I can figure out where the center of drag would be. Basically, I just want the majority of the sword to be behind that line, but if I move the handle forward and it flies better, I know that that probably means that having that center of mass line, I don't know what to call these things because I'm not a physicist, but I do understand this concept. If the line goes to here instead of back here, the sword flies better. And the handle is slightly curved in the picture, but not as much as I curved it. But you know, I'm trying to make this thing functional, so it can't be perfectly accurate. But the important part of the swivel point then, it has to be lined up perfectly parallel to that mass line. That way, the links of the chain don't have to try to cam over for this to be able to spin, because if I spin the chain around like this, the chain is spinning and the sword should not be. So that needs to be perfectly lined up. And the only benefit to moving the handle back here is that a circle is incredibly not aerodynamic at all. So that will cause a lot of drag on the back of the sword. It adds weight to it, so hopefully that just cancels out. I don't know. We'll find out. But because this is angled forward, the cross section of it would be more like an oval, which is more aerodynamic. Hopefully it adds drag at the back and doesn't add drag towards the front because it's actually kicked forward. I won't know until this thing is finished. Bought this 3D model online from Cults 3D, printed it out of nylon, so it should be relatively impact resistant, but this is not to the same scale as my blade, so it's gonna take some modification to get this thing on. And it's made to be put together in parts that are 3D printed, so like the blade slips into that and the handle slips into that. My handle needs to go through that and the blade fit on. My blade's wider. I need to hog that material out, and I need to wallow out a hole for the handle to go through. Then I'll paint it. That way I don't screw the paint job up in advance. I haven't drilled a 1-inch hole in a 3D print before, but I have a sneaking suspicion that trying to do it with this wouldn't work very well. So I'm gonna use a carbide burr. I really thought this carbide bit would work, but it's not cutting, it's just melting. So I'm gonna try this. This is one of those drywall zip bits for a Dremel. Maybe this will do the trick. Ugh. Nothing like a good set of needle nose pliers to destroy your 9-hour print that you just made. I don't plan on this thing really taking much impact. I'm not too worried about the tolerance around the handle because this thing goes up over the blade so much. As long as it's secured there, I think it's gonna be fine. Famous last words. Also, that's not actually my mom. If you want a goofy name on the table, you can join my Patreon. Whatever name you want on my work table, I'll put it on there. Even if you want it to say Garris's mom. It's only $1 a month. You get access to extra content. You get your name on the table, and I'll send you the templates and files from the builds that I do, at least the ones that I can. Can't send this one because I bought it, and that would be stealing. But yeah, Patreon, link in the description. This thing is not cutting, it just wants to melt the plastic. And if the plastic wants to melt, so be it. I'll make it fit with this. This softens around 400 degrees Fahrenheit, I think. Probably gonna have to put these welding gloves on before before I really get into this. Hopefully I don't have to actually get it up to 400 to get it soft enough that I can squish it down on and let it cool back down and take that shape. Oh, it wants to go. Oh, it needs to spread out just a little bit. It's almost there. Nearly there. Let's really put some heat into this thing. I have no idea how to eyeball 400 degrees, but let me give it a shot. And you're almost there. It's starting to go different colors on the handle, so I know that that is hot enough because I'm pretty sure steel turns straw colored right around 400. Ah, yes! That took longer than it should have. I need to wait for this to cool completely, and hopefully it will hold the shape that it's in like this, and I can pop it back off, because now that I have it shaped, I can paint it and put it on. Upon close inspection of the picture, the guard is not silver. It's like a brassy bronze type of color, but obviously old looking and dark. I have antique brass metallic that's been sitting over there on my shelf. I'm gonna use this for the base coat. Oh. You know what? I'm being stupid. I need to prime this because it's epoxy with universal bonding primer. That's wonderful. Acetone. Let's try this again with the correct paint first. Now, the antique brass metallic. And the keyboard warriors, you can settle down. I just go outside and paint the rest of it. You're not looking. Come on. I was intentionally not careful when I put epoxy on this thing so that it would have more screwy areas to hold the weathering stuff. And I messed it up even further when I tried to get it to fit onto the sword. So it should look good with the weathering. And the ultimate question is, can I get it back on? Because after it cooled, it was difficult to take off. Very, very tight. No, I just snapped the tip off of that. That's what God invented super glue. There it is. Okay. I want this to be removable, so the only way to do that, or well, it's not the only way, but the best way to do it is to weld this. It's a pinch lock nut where the nut is shaped squished so that it holds onto the bolt. I'm gonna weld it to this washer, and then I'll weld that to the end of the handle. That way I have a captive nut inside of the handle that the bolt with the swivel point goes on. Here we go. It helps if you turn it on. For my next trick, I weld the washer to the tube. I didn't need a bolt that was this outrageously long, but it was the shortest bolt in this size that had a shaft on it instead of being completely threads. But when the bolt goes in, it pinches a 608 ball bearing between one washer on the top and 3 on the bottom, which allows it to spin very freely. And then this big washer will be connected to that ball bearing, and that will spin freely. And then I just need to weld a piece of chain onto it and somehow make it pretty. And I haven't decided which pommel I want to put on because there's like a bunch of different options from the game. So I'm gonna wrap the handle. I'd like to go get leather that's the exact color, but I don't want to spend the money and I don't want to go to the store. And I have some leather dye here, so I'm gonna use this white stuff that I got from a piece of furniture from somebody a long time ago. The handle is 1/19 the length of the sword, which comes out to 1.5 inches, I think. I wrote it down somewhere. It's supposed to be 1.4 inches thick diameter. This is 1 inch, so I need to add 1/4 inch on both sides, 1/2 inch. Oh man, 1.395. Now I need to make this twice as long as it is. Because this is finished leather, I don't know if it has glaze on it or not, but I've been told that you should deglaze it so that the dye takes better. I'm pretty sure I did this before. This is what you're supposed to use, but the progress doing this is, it's a little slow for me. I'm gonna use a rag. You know what? It says dark brown, but if I leave it like that, that's pretty close to the right color. It needs to be a little bit more red, but that'll do, pig.
That'll do, pig.
Yep. here goes. It's wrapped what it looks like from the bottom up. I think it's actually just like rings set on top of each other of leather. It's real strange looking. Would you look at that? It isn't super even, but I can redo that later. Yeah, that's gonna work just fine. Well, there's one almost done. I still need to decide on that pommel so that I can connect the chain to it. And then get to do the second one because I vastly underestimated how long all of this would take and how difficult it was gonna be. And I'm way behind on this project. But next time they will be completely finished. I'll put the little notches and I'll rewrap the handle and I'll put the pommel on, it'll be connected to the chains and I'll go out and I'll use them just like Kratos and they'll fly right and oh, it's gonna be awesome. I am actually really excited for that, even though I'm really tired right now. So if you want to see that, make sure you're subbed with notifications turned on, you know, all that stuff. Anyway, I will see you next Sunday when I actually get to use these things. Bye.